Welcome to Presidents and the Central Limit Theorem. In a study done on the age at inauguration of all the presidents of the United States, the mean age was 55 years old and the standard deviation was 7.5 years. So first of all, we need to note that the mean here is 55 years old and the standard deviation is 7.5 years. So we have to answer, what is the probability that an individual president selected at random will at most be 50 years old? So while we're doing this problem, we have to note that the word at most 50. In our probability statement, at most means less than or equal to, and then 50. So we have P, open parentheses, x less than or equal to 50 equals. Now, in order to find this probability, we're going to use StatCrunch. Let's go ahead and use StatCrunch. Under StatCrunch, we're going to go to the Stat feature, and then we're going to go to Calculators, and then we're going to use Normal. At this point, we're going to have to enter the mean and the standard deviation. So in this problem, we're going to change the mean to 55 and the standard deviation to 7.5. Then x, we're going to use, remember, at most is less than or equal to, and we're going to change that 0 to a 50. And then go ahead and hit compute. So it gives us several different parts to this problem. The first part is the graph, and we're going to have to draw this curve. So in order to draw the curve with our current mean of 55 and our standard deviation of 7.5, we're going to click the 68, 95, 99.7 tick mark, and that will display our answer. So from here, we can tell that our probability answer is 0. I'm going to round to 4 decimal places, 2525. And on our curve, notice our mean is 55, and I'm going to draw out to 2 standard deviations above and below the mean. So I'm going to draw 40, 47.5, our mean of 55, then 62.5, and 70. Since x actually is equivalent to the 50, we're going to draw approximately where 50 is and write it as x equals 50, and then shade to the left since it's less than or equal to. We're also going to label that area. That area we're going to label is 0.2525. So StatCrunch does a lot of it. Notice I do want you to label the x value and the area or probability. So now on our sentence. Our sentence is going to say, if one president is randomly selected, the probability they are at most 50 years old is approximately 0.2525, or, and I'm going to write it as a percent, so 25.25%. Continuing on, we're going to now look at a sample of 16 presidents that are randomly selected, and we're going to find the probability now that the mean age will be at most 50 years old. So with this one, again, we're going to find the mean age, and instead of one president, it's a sample of 16 presidents. Notice it's going to still be at most 50 years old. So since 16 presidents are going to be randomly selected instead of 1, we're going to use what's called the central limit theorem. And in the central limit theorem, it says here it says that since there are 16 presidents randomly selected, that means we're going to use the central limit theorem. And in the central limit theorem, we're going to use the same means. So the mean of the sample means is still going to be our 55. But what we're going to have to do is change our standard deviation. So the standard deviation of those sample means is going to change. And it's going to change with this small little formula that says we're going to take the current standard deviation and we're going to divide it by the square root of the sample size n. So in this case, we're going to take our standard deviation of 7.5 and divide it by the square root of n, so it's 16. Let's use our calculator. On our calculator, we're going to take 7.5. Then we're going to divide it by the square root, second square root of 16, and hit enter, and that's going to be 1.875. So we're going to keep our keep our mean of 55, but our standard deviation in our problem is going to change now from 7.5 to 1.875. So we're still going to use StatCrunch for this. Notice our probability statement is going to be probability, then parentheses x bar is now going to be less than or equal to 50. So notice instead of x, we're using x bar. On StatCrunch, we keep the 55. We're going to then change our standard deviation from 7.5 to 1.875. Hit compute. This changes our probability. Again, I'm going to make sure I hit the 68, 95, 99.7% tick mark to get my accurate readings on my bell curve. Labeling my curve, I'm going to get 55 is our mean, my 56.9, 58.8 to the right, 53.1, and 51.2. Notice I'm going out to 2 standard deviations. It's not necessary to do the full thing. Then 50 is just to the left of 51.2, so that's going to be x bar equals 50, and I'm going to shade that teeny tiny little area to the left. And I'm going to label that new area as 0.0038. So that area is 0.0038, so that means my probability answer is 0.0038. Now for the sentence. So since we're selecting more than one president, it's going to be a little different. And remember, we're calculating the probability that the mean age will be at most 50 instead of just the one person's age, okay? So a sentence is going to look like this. If 16, okay, presidents are randomly selected, the probability the mean age is at most 50 years old, is approximately 0.0038 or 0.38%. That's extremely small. So the probability that 16 president's mean age is less than or equal to 50 is 0.38%, which would definitely be unusual. So to summarize this, the reason to use the central limit theorem is if more than one is randomly selected, and we're going to be calculating the probability of the mean age instead of just the regular age.